Welcome back to the session, and today we'll have a recurrence relation, right? The discussion for today's thing is we'll have the topic recurrence relation. What is meant by recurrence relation, right? Relation in the sense there will be a relation like say for example height of father, height of mother, height of father, height of son, height of likewise we'll have. So that is kind of a relation. What is about this recurrence? Recurrence means, literal meaning is we have to repeat, right? We have to repeat. So that is recurrence, recurring, right? So that is recurrence. Now, what is all about this recurrence relation as far as this discrete mathematics is considered, or since because we are all computer science or IT, information technology students, how far this recurrence relation will be helpful for our side. So in that case, if we have to think over, we are good at coding or we are good at programming, right? So how do we get a solution? We get an outcome or a solution for any program only if we run it repeatedly, right? So this recurrence relation is also such kind, that is a relation. A recurrence relation is a relation that allows us to run on and on through the terms of sequence. So mathematically speaking, I can say it as terms of sequence, but being a computer science student or an information technology students, we'll be running on and on through the program until we get the desired result. So until we get output, we'll be just running on and on through the program. So for those kinds, this recurrence relation will be used. So now a recurrence relation is a relation that allows us to run on and on through the terms of sequence. So it has to be done in a sequential manner, right? So now an equation that expresses an in terms of one or more of the previous terms of sequence, namely a naught, since because I have said it to be a sequence and there are n number of terms, a naught, an, a1, a2, so on till a minus 1, an minus 1 for all integers n with n greater than or equal to n naught, where this n naught, it should be a positive integer. So this has to be performed for repeated number of terms or a sequence. So now what is all about a recurrence relation in a mathematical manner? Let us see, right? We will have an equation as C naught an plus C1 an minus 1 plus C2 an minus 2 plus so on Ck an minus k is equal to f of n. So now here this is called as a recurrence relation, and this will be called as a homogeneous recurrence relation whenever our f of n is equal to 0, right? So whenever our f of n is equal to 0, the equation will be called as homogeneous recurrence relation, and whenever our f of n is not equal to 0, it is non-homogeneous recurrence relation. So that is the difference between homogeneous and non-homogeneous, and that too it is said to be a linear recurrence relation. Why it is said to be a linear recurrence relation is that you just look into the power of each and every a term. The power of each and every a term is only 1. So that is why it is a linear recurrence. And what's the degree of this? So the degree of this is k, alright? So the degree of this is k. How do I fix the degree here is that it is the difference between the highest and the lowest subscribed. So the degree, how do we fix here? The difference between the highest and the lowest subscribed. So the highest subscript here is n, right? N minus of the difference is n minus k, which is equal to, so n minus n plus k, so which is equal to k. So that is why we say the degree of this difference equation or a recurrence relation, it is said to be as k. and this will be of degree k provided that your Ck should not be equal to 0. That is very, very important. Suppose in case if Ck happens to be 0, this term will not be there, it will have only till the previous term. In that case, the degree will not be k and it will be some other, alright. So now in order to find out the degree of any given recurrence relation, we will have to take the difference between the greatest subscript and the lowest subscript. The difference between these two subscripts will give us the degree of the equation, and we will have to see to that the coefficient of that term should not be equal to 0. What happens if it is equal to 0? So in that case, we will not have the degree to be as k, we will have something else. And the recurrence relation, it is said to be as homogeneous whenever the right hand side f of n, if it is equal to 0. And if it is not equal to 0, we will have it to be as a non-homogeneous recurrence relation. And why do we call it to be as a linear recurrence relation? Each and every term a, we have the power as 1. So therefore, that is why it is called as a linear recurrence relation. So this is all about the recurrence relation. And how do we solve such kind of a recurrence relation? Using a generating function. So first of all, let us see what is a generating function. So generating means it generates something, right? So sequence, it is in a sequence here, orderly manner. So generating sequence means that will be generated in a sequential manner. Something has to be generated or something will be generated in a sequential manner. See for how does the definition goes. The generating function of a sequence a0, a1, so on till it goes till infinity also it may go. It is defined to be as, first of all, generating function will be denoted as g of x, which is a0 plus a1x plus a2x square plus so on till infinity. So now this is equal to, since because we are summing it up, we will have summation in general, and it ranges from 0 to infinity. So therefore our n ranges from 0 to infinity. So we will have an x power n. So now see, when I substitute n as 0, I get a0 x power 0, anything power 0 is 1, so that I get it to be as a0. When my n is 1, I will have a1x, that is my second term. When my n is 2, I have a2x square, that is my third term. Likewise, it keeps going till the last term infinity. So this is what about the generating function. So generating function, it generates something in a sequential manner. That is all about generating function. And now see, specifically we have some terms. Let us see that also. The generating function for the sequence 1, 1, 1. So what will be the generating sequence for the terms 1, 1, 1, so on? We will have to think over. So generating function, in the sense it has to be sequentially generated. So all this a0 is 1, a1 is 1, a2 is 1 and so on. So how do I have? So it will be 1 plus x square plus so on. So in that case, see, my a0 is 1 here, a0 is 1, a1 is 1, a2 is 1 and so on till my infinity term. So everywhere I have only 1, no? So therefore my g of x will be equal to summation, my an all is 1, I will have only x power n equal to 0 to infinity. That is what I have here. So now this is equal to, give the value of n as 1, 0, anything to the power of 0 is 1, 1 plus x square plus so on till infinity. And this it can be written as 1 minus x raised to the power of minus 1 using the binomial expansion. And that is what 1 by 1 minus x. So this is the generating function for the terms 1, 1, 1, 1 so on till infinity. And next likewise we have also one more thing. The generating function for the sequence 1, 2, 3, 4 so on till infinity, what it will be. So let us check over here. So my a0 is what here? 1, my a1 is 2, my a2 is 3 and so on. So now putting into this form, my g of x will be equal to summation. Why do I have n plus 1 here is that my a0 is 1. Right, my a1 is 2, so one term is increased here. So that is why I will have n plus 1 into x raised to the power of n. So just expand it, I will have this to be as n is 0 na, I will have 1. Then when n is 1 na, I will have 2x, then I will have 3x square plus so on till infinity. So now this is equal to 1 plus 2x plus 3x square. Apply the same thing, I will have 1 minus x the whole power minus 2. So that is 1 by 1 minus x the whole square. This is how the generating function can be done for a given sequence of numbers. Now, for a given recurrence relation, we will make use of the generating function and we will try to get a solution for that given recurrence relation. First of all, what did I say about the recurrence relation? It is a sequence which allows us to run on and on through the given terms. So now let us see that, and we will make use of this generating function to solve it. So using generating function, solve the recurrence relation. This un minus 1 minus 2 un minus 2 is equal to 0 with u0 is equal to 5 and u1 is equal to minus 3. So now how do we solve this? First thing is that what kind of a recurrence relation is it, we will have to think over. Is it a homogeneous or a non-homogeneous? Very damn sure that since because our right hand side is 0, we don't have a function of n here. So whenever your function of n is missing, it is equal to 0, then it is said to be a homogeneous recurrence relation. Fine. Then what is n is not given in the problem. Fine, if it is not given, still we can find out. So for what values of n it will be true, we can find it. What will be the degree of the equation? So what did I say? How do you find out the degree? The degree is nothing else but the greatest subscript minus the lowest subscript, right? We'll just find out the solution for the problem here. How do I find out the degree? So the degree is nothing else but the largest subscript minus the lower subscript, which is equal to 2, the degree. So which means that this will be valid for n greater than or equal to 2. Right, the entire recurrence relation, it is true for n greater than or equal to 2. This is how we will have to fix up your n value. Then what should we do? So what is the, we will have to use generating function. So generating function is what? G of x is equal to summation n equal to 0 to infinity an x power n. So an in the sequence is u here. So instead of a, I will have un x power n. So now first let me write down the equation as it is. Un minus 1 minus 2 un minus 2 equal to 0. Number this equation to be as 1. Right. So now I have to multiply 1 by right, appropriate power of x. So appropriate power of x in the sense, in these subscripts, whatever may be the greatest subscript, that I will have to take the power of x and then I will have to multiply. So why do I need to multiply it exactly is that since because we have to make use of the generating function and we will have to solve it. So generating function ka I need my x. So appropriately I will have to multiply this equation by x raised to the power of power. You will have to fix it here. Power should be the greatest subscript. Least is n minus 2, n minus 1 and the greatest is n. So that is why I will have to multiply this by x to the power of n and sum it from n is equal to 2 to infinity. So since because n value is not given, I have got my n but just finding out the degree. So it will be true for all n greater than or equal to 2, then I will have to sum it up. So I will be multiplying x power n for each and every term and I will be summing it from 2 to infinity minus summation n is equal to 2 to infinity un minus 1 x raised to the power of n, right, minus 2 into summation n is equal to 2 to infinity un minus 2 x raised to the power of n. Since my right hand side is 0, 0 and anything becomes 0. See here, for each and every term I have multiplied it by x power n and then I have summed it from taking n is equal to 2 to infinity. You may ask me, why should we sum it up? Why should we multiply? Since because we are making use of the generating function and the generating function, it is of the form summation an x power n. So that is why we are appropriately multiplying by the power of x and then suitably summing it up from n is equal to 2 to infinity here. And now here n is equal to 2 to infinity. You just substitute n as 2. What do you get? U to x square n is 3, u3, x3 plus so on. So, I will have these terms minus n is 2 now, I will have 2 minus 1 is 1, then x power 2 I will have. So, what I will do is that even before substituting it, now I will make the subscript and the superscript as one and the same. In order to make by subscript as well as the superscript one and the same, I will remove one x outside. I may take one x outside. So, taking this x outside, I will have sum is n is equal to 2 to infinity u n minus 1 x raised to the power of n minus 1. See here, if I bring this x, it will be x power n. So, this summation is valid only for n and not for x. So, that is why I have taken 1 x. Likewise, here also, see here I have n minus 2 and here it is only n. So, now in order to make the subscript match with that of my superscript, I will have to take one x square outside. Take this x square outside. So, I can write this to be a summation 2 to infinity u to the u n minus 2 x raised to the power of n minus 2 equal to 0. Now, if I bring this x square inside, I will get it to be as x to the power of n, right. So, now everything is over. Next step is that somehow I should try to apply my generating function. My generating function, what it says here, see here I will have u0 plus u1x plus u2x square plus so on till infinity. So, likewise only I have few of the terms are missing. So, what are all the missing terms? I will have to add and subtract the missing terms. So, when I add and subtract it, what are all the terms that I will add and subtract? My u1 and u0 are missing here. So, I will be adding and subtracting it. So, it will be u0 plus u1x. I am adding it with the rest of the terms u2x square plus u3x cube plus so on. And what should be the term that I will have to subtract it? It is u0 minus u1x, right. So, if I add and subtract something at the same term, the value of that term will not get altered. So, then minus x into, when n is 2, what do I get? 2 minus 1 u1 x to the power of 2 minus 1 x u2 x square plus so on till infinity I will have. Next is minus 2x square, n is 2 now I will get u0, u0 x power 0 is 1 plus u1x, when n is 3, when n is 4 I will get the next term equal to 0. And now see here, combining all these terms, right, these terms till here, it is the generating function, right, it is the generating function. So, I can write this to be as g of x minus u0 minus u1x minus x into, see here, if I want to express this as my generating function, compare this with this, u0 is missing. So, then I will add and subtract my u0 here, u0 plus u1x plus u2x square plus so on minus u0. I have added and subtracted this u0, right. I have added and subtracted the u0. And next is I have minus 2x square. I need not add or do something else, since because all the terms of my generating function here it is present equal to 0, right. So, my g of x minus, what is my u0? u0 is given to be as 5 here, 5, and what is my u1? u1 itself is minus 3, minus of minus becomes plus 3x minus, so all these terms x into, till here I have my g of x, u0 plus u1x plus u2x square, everything it is g of x minus u0. What is my u0 value? That is 5 in the problem. See here, u0 is 5 minus 2x square, and I have the entire term g of x is equal to 0. So, now I will pool all my g of x to one side and I will take the rest of the terms to the other side. So, g of x, the coefficient here is 1, then the g of x coefficient is minus x, here I have the coefficient to be as minus 2x square into g of x, right? I will have minus 5 plus 3x minus to minus is plus 5x is equal to 0, or it will be 1 minus x minus 2x square into g of x is equal to this minus 5 when it goes to the other side it will be plus 5, and this 8x when it goes to the other side it will be minus 8x. So I will have to solve this for my un. So my g of x will be equal to 5 minus 8x divided by 1 minus x minus 2x square, right? So now I'll try to write this in terms of a quadratic form, then I will factorize it. After that we will undergo the partial. Somehow I should find out what is my un. So which is equal to, I'll 5 minus 8x divided by 1 minus, I will take it outside, 2x square plus x minus 1, that is equal to this minus. If I multiply it with the numerator, I will have 8x minus 5 divided by 2x square plus x minus 1. Now here I will have to see, if I keep this term as it is, I will not be able to get my un. So what I will have to do is that I will try to factorize my denominator term. So factorization, you might be good. Suppose in case if you are not good at factorization, you go with this thing. That is, if you have ax square plus bx plus c equal to 0, how do I find out the root of x here? It is minus b plus or minus root of b square minus 4ac by 2a. That formula you have, no? Make use of that formula and get the value of x here. So in that case, what is your a value in the problem? A is 2 here, b is 1, c is minus 1. Your x, it will be equal to minus b plus or minus root of b square minus 4ac. So minus 4ac, 4 into 2 is 8. 8 into minus 1, so I get it to be as plus 8 divided by 2 into a here, so it is 4, which is minus 1 plus or minus root 9 is 3 by 4. So minus 1 plus 3, I get 2, 2 by 4, it is 1 by 2, and minus 1 minus 3 is minus 4, so I will get it to be as minus 1. So the factors of this term are, it will be x is equal to, the roots are x is equal to 1 by 2 and x is equal to minus 1, or I will get 2x minus 1 equal to 0 or x plus 1 equal to 0. So now see here, my g of x, I will just have that carry over here. My g of x will be equal to 8x minus 5 divided by 2x square plus x minus 1, and the factors of this are 2x minus 1 and x plus 1. So this it can be written as 8x minus 5 divided by 2x minus 1 into x plus 1. Alright. So now we just make a product and we will see whether we are able to get this. 2x into x is 2x square, 2x minus x is plus x minus 1, fine. So now we will undergo the partial fraction for this and then we find out what will be our solution for un. Now consider the term 8x minus 5 divided by 2x minus 1 into x plus 1. This it can be written as a by c here. If I undergo the partial fraction, the denominator is linear and non-repeated, so that I will get it to be as a by 2x minus 1 plus b by x plus 1. Now take a common LCM, find out the values of the unknowns a and b. So I will get this to be as, here I have 2x minus 1, so x plus 1 is missing, multiply it, plus b into 2x minus 1 is missing. So on either side my denominator will get cancelled, right? 2x minus 1 into x plus 1. On either side my denominator will get cancelled. So I will have 8x minus 5 is equal to a into x plus 1 plus b into 2x minus 1. Now in order to find out the values of unknowns a and b, we have two ways. One way is by equating the like terms and getting it, we can get it. If not, the easiest way is that we will see to that any one of the term vanishes for an appropriate value of x, and then we will get it. Suppose if I give the value of x as minus 1, what do I get? So it is minus 8 minus 5, which is this term will go off, minus 1 I will have minus 2, which is minus 3b. So from here this will imply minus 13 is equal to minus 3b, or this will imply my b is equal to 13 by 3. Then I'll see to that this term vanishes. For what value of x this term will vanish? X is equal to 1 by 2, 2 or 2. So I'll just substitute x is equal to 1 by 2. So x into 1 by 2 I'll get 4, 4 minus 1 is equal to 1 by 2 plus is 3a by 2, right? And 1 by 2, 2 cancels, 1 minus 1, 0 I'll get it. So this will imply minus 1 is equal to 3 by 2a, or this will imply my a is equal to minus 2 by 3. So these are the values of a and b I get, right? So after getting the values of a and b, now substitute it. So this is what a by. So a by na, a value is minus 2 by 3 by 2x minus 1, plus what is your b value? B value is 13 by 3 by x plus 1. And what is our g of x? G of x is summation n is equal to 0 to infinity un x bar n, right? So this is my generating function, and this is equal to this. And now we are supposed to find out what is un actually. So this is equal to, we'll see to that whether our denominator is either 1 plus or 1 minus. So we'll try to bring that into that form. So it is minus 2 by 3, I will take outside it. This is 1 by 1 minus I should have. So it is 1 minus of 2x. See here I will have minus 1 plus 2x. Okay, fine. Plus 13 by 3 I will take it outside, then it will be 1 by 1 plus x. So take it to the numerator. So this minus and minus will go off, 2 by 3 into 1 minus 2x the whole raised to minus 1, plus 13 by 3 into 1 plus x the whole raised to minus 1. So which is 2 upon 3 into, it is of the form 1 minus x the whole power minus 1. So what is 1 minus x the whole power minus 1? We know according to the binomial expansion, it is 1 plus x square plus so on till infinity we will have. So that way if I do it, I will have x itself is 2x here, 1 plus 2x plus 2x the whole square plus so on, plus nth term I will have 2x power n plus so on till infinity, plus 13 by 3 into this 1 plus x the whole raised to minus 1, alternate I will get plus minus 1 minus x plus x square. See, alternate plus minus I am getting it. So for the nth term I don't know either way it will be minus or plus. So I will have it to be as minus 1 whole raised to n and x to the power of n. So it will be 1 minus x plus x square plus so on till, plus minus 1 power n x power n plus so on till infinity. So now here if you want you can just expand it also. If I expand it, I get this to be as u naught plus u1x plus so on till un x power n plus so on till infinity. Now our intention is to find out un. So where is un? It is equating the coefficient of x power n on either side of the equation. The coefficient of x power n is what here? Un. Un is equal to, I have 2x whole power n. So 2x whole power n, I can write it to be as 2 power n into x power n. So I have outside 2 upon 3 into, what is the coefficient of x power n? It is 2 power n, plus this 13 by 3 I will have, what is the coefficient of x power n? Minus 1 to the power of n. So this becomes the solution for the problem. And even if I want to check out my answer is right or wrong, right, what is the given u naught is what value of u naught we have? U naught is equal to u naught is equal to 5 and u1 is equal to minus 3. This is what is given. We will have a cross check for, right. So cross check is substitute n equal to 0, you will have u naught is equal to 2 by 3 into 2 power 0 plus 13 by 3 into minus 1 power 0. So, 2 by 3, anything per 0 is 1, anything per 0 is 1 plus 13 by 3, which is 15 by 3, that is 5. I am able to get this 5 here, fine. And next n is equal to 1. u1 is equal to 2 by 3 into 2 raised to 1 plus 13 by 3 into minus 1 power 1, which is 2 power 2, so it is 4 by 3, and minus 1 is minus 13 by 3, which is minus 9 by 3, which is minus 3. That also I am able to get it. See here, whenever we make use of generating function and we solve any of the recurrence relation or a difference equation, at the end, after getting a desired result, we can have a cross check of the problem whether it is right or wrong. So now I will substitute n is equal to 0 and n is equal to 1. With that, we are able to get the values of the given initial thing as 5 and minus 3. So that I can confirm that my desired result for un is correct after using the generating function for this recurrence relation. Thank you. So, back again here, again using the generating function, we will solve a recurrence relation for an is equal to 4an minus 1 minus 4an minus 2 plus 4n, 4 power n for n greater than or equal to 2, given a0 is 2 and a1 is 8. So, in the previous thing, we had it to be as linear homogeneous recurrence relation, and here it is a linear non-homogeneous. So, let us see how do I say it to be as a linear non-homogeneous. So, I will take all my a's to one side. I will have an minus 4 an minus 1 plus 4 an minus 2 is equal to, see here in the right hand side, I am able to get a function of n. So, therefore, I can say it to be as a non-homogeneous. Again, in a similar manner only we will have to do it, but then it is a non-homogeneous. I have taken one for a homogeneous, the other one for non-homogeneous. So, now what should I do? Let me keep this equation to be as number 1. What I have said in the previous thing, we will have to follow it exactly, and only thing is that we have a difference that to be as a non-homogeneous recurrence relation. So, here this 1 has to be multiplied. 1 has to be multiplied by appropriate power of x. So, appropriate power of x in the sense, I will have to find out the greatest subscript. So, what is the greatest subscript here? N is the greatest. So, I will have to multiply it and then sum it for n is equal to 2 to infinity, right. So, now let me multiply. So, summation n is equal to 2 to infinity an x power n minus 4 into summation an minus 1 x power n is equal to 2 to infinity plus 4 into summation n is equal to 2 to infinity an minus 2 x raised to the power of n is equal to summation n is equal to 2 to infinity 4 power n into x power n. Right. So, now after multiplying it by appropriate power of x and then taking up the summation for n is equal to 2 to infinity, the next step what I will have to do is that I will have to check out whether my suffix and my superscript are one and the same. That is, this is okay, quite good, and this is n minus 1 and here n I have. So, I will make this to be also as n minus 1 for our easy purpose, simplification purpose, for which I will remove one x outside. From here I will take one x square outside. So, with that I will have summation n is equal to 2 to infinity. I will have an x raised to the power of n minus 4x summation n is equal to 2 to infinity an minus 1 x power n minus 1. So, this x when it comes inside the summation I will have plus 1. So, it is x power n plus 4 into, I will take one x square outside, summation n is equal to 2 to infinity a n minus 2 x raised to the power of n minus 2. So, if I bring this x square inside now, I will get it to be as x power n, which is equal to summation n is equal to 2 to infinity. I can have this to be as 4x the whole power n, since because the power of both the terms are n over here. And now let me use my generating function. So even before I use a generating function, I will substitute n as 2 to infinity here. When n is equal to 2, I get this to be as a2x square plus a3x cube plus so on till infinity. Then minus 4x into n is 2 na, 2 minus 1, a1 x to the power of 2 minus 1 is 1 plus a2x square plus so on we will have plus 4x square into n is 2 na, I will have a naught, x bar 0 is 1 plus a1x plus a2x square plus so on I will have. That is equal to, I can have this term as it is, n is equal to 2 to infinity 4x the whole power n. And then if I want to make use of the generating function, it is of the form a naught plus a1x plus so on. So whatever the terms are missing over here, I will be correspondingly adding and subtracting it in order to make use of that generating function. So I can add of this a naught a1x here, right, adding to this term a2x square plus so on minus whatever term I have been added, I will have to subtract that. So only then the value will not be altered. Minus 4x, here if I have to make use of the generating function, a naught is missing. So I will add a naught, then I will subtract that a naught. Here no need, since because it is exactly of generating function, I will write it to be a simply g of x, right, 4x square into g of x, which is equal to, I can give the values over here. N is 2 na, I will have 4x the whole square, n is 3 na, I will have 4x the whole cube plus so on till infinity. Now see here, all these terms I can write it to be as g of x. Minus a naught is what here? 2. Minus a1 it is minus 8x, right. Minus 4x into all these terms are g of x and minus a naught is minus 2 here plus 4x square into g of x is equal to, I can take 4x the whole square outside, then it will be 1 plus 4x plus 4x the whole square plus so on till infinity. Now I will pull off all my g of x to one side. So the coefficient of g of x is 1, here it is minus 4x and here it is plus 4x square into g of x. So it is minus 2 minus 8x, minus 4x into minus 2 becomes plus 8x is equal to 4x na, I will have this to be as 16x square and it is of the form 1 plus x square plus so on. So that I can write it as 1 minus x the whole power minus 1. Alright. So now plus x minus 8x and plus 8x will get cancelled here. Then I will have only g of x in the left hand side. So 1 minus 4x plus 4x square into g of x is equal to 16x square into 1 minus 4x power minus 1. This minus 2, if it goes to the other side, I will get it as plus. So now this I will do the simplification. It is 16x square by 1 minus 4x plus 2, or this it will be equal to 16x square plus 2 minus 4x by 1 minus 4x, or my g of x will be equal to 16x square minus 4x plus 2 divided by 1 minus 4x and 1 minus 4x plus 4x square, or this it will be 16x square minus 4x plus 2 divided by 1 minus 4x into 1 minus 2x the whole square. Just expand this. 1 square is 1, b square na 4 plus 4x square I will have, minus 2ab in the sense 4x I will have. Fine. So now for this I will have to undergo the partial fraction and then we will have to do it. So partial fraction we will consider the term here 16x square minus 4x plus 2 divided by 1 minus 4x into 1 minus 2x the whole square. So that is equal to a by 1 minus 4x plus b by 1 minus 2x plus c by 1 minus 2x the whole square. Next is, I will take a common LCM in the denominator of the right hand side, and then I will do the simplification. So we will have this, which is equal to, when I take a common LCM, I will have 1 minus 4x into 1 minus 2x the whole square. So it will be a into whatever term is missing. So here 1 minus 2x the whole square is missing. I will have this 1 minus 2x the whole square, plus b into 1 minus 4x is missing, 1 minus 2x is missing, plus c into 1 minus 4x alone is missing. On either side, my denominator will get cancelled, and we will have 16x square minus 4x plus 2 is equal to a into 1 minus 2x the whole square plus b into 1 minus 4x into 1 minus 2x plus c into 1 minus 4x. And as I have already said that getting the values of the unknowns a, b, c, either I can equate the like terms, or I can randomly give the value of x and I can get the values of a, b, c. That way we do it. So now let me give the value of x to be a, suppose in case if this happens to be 0, na, for what value of x it will be 0. So in that case I will have 1 by 2, 2 will get cancelled. So x is equal to 1 by 2. So 1 by 2 na I will have 1 by 4. So for 16 by 4 I will get it as 4 minus 1 by 2 na I will get 2 plus 2, which is equal, this term will go off, this term will go off, this term I will get 1 by 2 is 1 minus 2 is minus 1, minus c. So this will imply c is equal to minus 4. The value of c will be equal to minus 4. And next term, for what value of x, this will become 0, na? X is equal to 1 by 4. So x is equal to 1 by 4, and if I substitute it, 1 by 16, that becomes 1. 4 and 4 will get cancelled, minus 1 plus 2 is equal to, these two terms will go off. Here I will have 1 by 4, right? So 1 by 4 into 2 is 1 by 2. 1 minus 1 by 2 is 1 by 2. 1 by 2 the square is 1 by 4. So 1 by 4a. This will imply plus 1 minus 1 will go off. My a will be equal to 8. Then for b, I can give my value of x to be a 0. X 0, and if I give it, I will get 2 in the left hand side. X 0, I will get a. X 0 na, I will get it as b, and x 0 na, I will get it to be a c. So 2 is equal to, value of a is 8, value of b I will have to find out, and this is, that is 2 is equal to b plus 4, or my b will be equal to 2 minus 4, which is equal to minus 2. So the value of b is equal to minus 2 here.